Hello, this is paper 2 of the 2019 TMUA. So 20 questions. Might be one video, might be two. See how it goes. Find the coefficient of the x to the 4 term in the expansion of that. Well, they've given us an x squared on the outside, so we'll have to have an x squared from the bracket. So we need, what, 4 of those and 2 of those. That'll give us x squared, wouldn't it? So we're going to have a 2 to the 4 from that 2, and then we're going to have a 6 choose 2 or choose 4. Doesn't really matter. That's going to become 6 times 5 over 2, 3 times 5, 15 times 16, 240. Right, that was a fairly straightforward opener. That and that, factors of that. What is the value of 2p plus q? So we've got x equals minus a half will give us 0, and x equals 2 will give us 0. So, well, I'll do the bottom, well, I'll have to do both, but the bottom one's more obvious, isn't it, as to what we're multiplying out. Minus a half, that's minus an eighth, which is minus a quarter, plus p over 4, plus q. Subtract top from bottom, 16 and a quarter, plus 3 and 3/4 p is 0. Multiply everything by 4 is going to give 64 plus 1 is going to give 12 plus 3. Now I've got to divide by, 15s doesn't go, 5s go, 13 is minus 3p. So we've got p is minus 13 over 3. So what's q going to be? Go off the easy equation. Be minus 16 minus 4p, so plus 52 over 3 is 17 and a third minus 16, so 1 and a third. I've got to do what? 2p plus q, minus 26 over 3 plus 4 over 3, so minus 22 over 3. There we go. Question 3. A, B and C are real numbers. Given A, B equals AC, which of the following statements must be true? A is 0. Well, B could be C, so no. B is 0 or C is 0. Well, no, A could be 0. B is C. No, A could be 0, so none of them. That was a real gimme of a question. Consider the following conjecture. If n is a positive integer that consists of a digit 1 followed by an odd number of 0 digits, then final digit 1, then n is a prime number, right? So we've got a 1, load of zeros, odd zeros, then a 1. Here are 3 numbers, which is a counterexample of that conjecture, right? So we need a 1, an odd number of zeros, and a 1, so not 2 then. And it needs to be a counterexample of it being prime. Well, that one is prime, so it can't be that. But this one, that looks like it's that. So it's a positive integer, which it is. It fits that, fits that. So it's the right structure, and it says it's prime, but this isn't prime. So it's going to be that one, which is, there we go, D3 only. Right, again, that would seem fairly fine. Consider the following statement about the positive integers a, b, and n. A, b is divisible by n. Okay. The condition either a or b is divisible by n is necessary but not sufficient, sufficient but not necessary. Okay, right, so which combination? So a and b, well, it's certainly sufficient because it would work. But you could have, I don't know, 3 times 5 is 15. And we could divide that by 15, which doesn't go into these. So it's not necessary, but it is sufficient. So B. Right. Question 6. Student attempts to solve. This looks like the questions where, where have they gone wrong, if anywhere? Yes, it is. So what's he ended up with? 0, pi over 2 pi, 3 over pi. Right, so every pi by 2. Well, that's no good, because if you put 0 in, you get 1 plus 0 is 0 minus 1. So he's got it wrong. The student's messed it up. So where have they messed it up? We've got that to that. What have they done in this first? Oh, they've just taken 2 sine x off of both sides and then split it out. So that's fine. Then they factorised. Right-hand side is still fine. Left-hand side, sine x, tan x, minus sine x, minus sine x, plus cos x. Yeah, that seems fine. Then, oh dear, that equals, oh, that's terrible. Right, so step 3 is just all manner of awful. So we got D. Nice, they didn't make us work for that one. Which one of the following statements can the fact that 12 squared plus 6e squared equals 20 squared be used to produce a counterexample? Right, so this one, we want to be a counterexample of one of these four. A, B, and C are positive integers which satisfy that equation, and the three numbers have no common divisor. Then two of them, well, yeah, they do have a common divisor. They're all even. So it's not A, it just doesn't fit the setup. The equation a to the 4 plus b squared plus c squared has no solutions for which a, b, and c. Right? Do we have an a to the 4? 12 squared? No. Oh, here we go. 16 squared. That's 4 to the 4. So we've got 4 to the 4 plus 12 squared equals 20 squared. So it fits that format. Does have a solution, and they're positive integers. There we go. 7b. No need to read onwards. 8. A, B, and C are real numbers. A is less than B, less than C, less than 0. Right, so they're all negative. Which of the following statements must be true? So A is the largest in magnitude. So A squared will be larger than AB, and that will be larger than AC. So that's fine. This is greater than 0. So we've got something negative times something negative, yeah. And then this one, these are going to come out positive because we've got two negative numbers on either side. So A over B, no, that's going to be wrong because A is larger than C. So 1 and 2, E. Okie dokie. Large circular table, 40 chairs around it. What's the smallest number of people who can be sitting at the table already, such that the next person to sit down must sit next to someone? So if you've got to sit next to someone, we can't have 3 empty seats in a row. So if we go every third chair, like 1, 4, 7, 10, 13, 16, 19, 22, 25, 28, I don't really need to write these out, do I? 37, and we will need, because you'd have 38, 39, 40, so we will need 40. You'll have 2 people sat next to each other. But you can't do it in less than that, which is 14, D. Okay. PQRS is a quadrilateral labelled anti-clockwise. Which of the following is necessary but not sufficient condition for PQRS to be a parallelogram? Okay, so let's draw out something a bit wonky looking. So PQRS. PQ is the same length as SR. Okay, PQ is the same length as SR, and PS is parallel to QR. Actually, that could already, yeah, could that be wrong? Yeah, that could already be wrong, because you could do that, 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 and that. So that's not a parallelogram, that's a trapezium, but PS is parallel to QR, and those are the same length. So, right, that's not sufficient. Is it necessary though? So if I actually drew a parallelogram, so if it was that PQRS, so well, opposite sides have to be the same length, so we do need that, and these things, opposite sides, do have to be parallel, so it's going to be A, straight off. Yeah, again, don't have to read on. 11. An arithmetic series has n terms, all of which are integers. The sum of the series is 20. Which of the following statements must be true? The first term of the series is even. N is even. Right, so what is it? So we've got n terms. Everything's integers. Sum of the series is 20. First term of the series is even. Wait, no, you could just do 9 and 11. That's 2 terms. First term's not even. So no. Is n even? Well, no, you could just have 20. So that's no good. The common difference is even. So I don't know, what if we went up in ones? 1, 2, 3, 4, 5, 6. That's gone 21 though, isn't it? 6, 7. Could we, maybe, I don't know, might be able to shift these down. So go 28, but you'd have to shift it down to 21. Put an 8 on, 36. Yeah, that'd work. Move it down 2. Start at minus 1, 0, 1, 2, 3, 4, 5, 6. 21 minus 1. Difference is 1 and they are 20. So that doesn't work either. So 11 is A. Okay. Most students in a large college study mathematics. A teacher chooses 3 different students at random, one after the other. Consider these 3 possibilities. Right. The probability at least one of the students studies mathematics. The second student chosen studies mathematics. Well, that's got to be less likely because you could have any of them or specifically the second one. So it's got to be more likely that we've got R than S. And then all 3 of them study mathematics. Well, that's got to be less likely than S. So it's got to go that one. TSR. TSRF. Okay, that ended up being quicker than it looked as though it was going to be on first reading. The student approximates the integral. Oh, that thing is, we go trapezium rule. Right, it's an overestimate. Right, fair enough. Which of the following are necessarily true? If the student approximates that in the same way, the result will also be an overestimate. Yeah, that is going to be true, isn't it? Because sine squared is symmetrical. So if we're going from A to B, and then you go to the other side, from minus A to minus B, you're going to get exactly the same bit of the graph. But yeah, it's going to look the same, isn't it? It's going to look the same, yeah, because is it going to look the same? Or is it just that my picture's really rubbish? Right, let's try drawing that out again. Pretty sure this is going to look the same. So if I did one, we only have to do one cycle to it. So if you were going from, say, here to here, that would be like going from there to there. So you've got exactly the same shape on either side. So that's definitely going to be true. The first bit. If the student approximates, oh god, right, okay, cos squared instead, the result will be an underestimate. Right, so when do we get the overestimate? So we've got an overestimate for sine. Right, okay, so that means we must be doing, overestimate means it's curving that way, underestimate means it's curving that way. If I put cos on here, it would come down something like that. So the curve that way on sine is a curve that way on cos. So, and vice versa. So yeah, that is going to be true as well. Yeah, because they are opposite of each other. So I think it's both of them, which is D. Right, that was tougher than the previous 13. Consider the following statements about the polynomial p of x. A is less than b. So, right, the value, the gradient, and the rate of change of gradient are all less at A than they are at B. Which of these statements is a necessary condition for p of x to be increasing between those values? So, if it's going to be increasing, well, we have to end up on something higher. So we are going to have the first one. Then what can we say about the gradient? The gradient, does it have to be less? Well, no, I mean, you could do that. That would still be increasing, but you'd have a greater gradient there, so that's not going to work. And then the rate of change of gradient, well, we can mess around with that all we want, can't we? I mean, you could start off with a very quick change and then go flat. So you'd get a big change of gradient at the beginning and then very little change of gradient at the end. So that's not going to work either. So it's only going to be the first one. So B. Right. There's not been much algebra in this or numbers or anything. It's all been like logic questions. Question 15. The numbers A, B, and C are each greater than 1. Following logarithms all to the same base. What is the base? Well, is it A, B, C? Can't tell. God, that looks horrible. Or not enough information. Right, okay. So if we got base, we'll say it was base x. So we got x to the 7 is A, B squared, C. X to the 11 is a squared b c squared. X to the 15 is a squared b squared c cubed. Okay. What do I do? Do I just try these out? Let's see if it's any of these. What happens if I divide through things? I mean, I could divide through, could I? Is that going to help? I don't know, or maybe I'll just, I mean, if it was, I don't know, let's see how long it takes to try out values. I mean, say that was a, we'd have a to the 7 is a b squared c, a to the 11, well, I might as well actually do the division while I'm going through. So a to the 6 is b squared c, a to the 9 is bc squared, a to the 13 is b squared c cubed. So we got some similarities top and bottom here. So c squared is a to the 7. I mean, that looks pretty ugly. So that would be b is off the middle one. B would be a squared. So that just doesn't work, does it, on the top one then? Because you'd have a to the 4, b to the 7 over 2. That doesn't work. I don't know, maybe this is going to be the easier way to go about it. What if we had it with b's? You'd have b to the 5 is a times c. B to the 10, a squared c squared, that looks promising. B to the 13 is a squared c cubed. So that would be that c is b cubed from the bottom two. And that means that a would be b squared from the top one. So we'd have, yeah, top one would work. This one would be fine. And that one would be fine as well. Oh, right, okay, so it comes out of B. Yeah, okay. I mean, I wonder what would have happened. I mean, because the other thing I was thinking of doing was maybe dividing the third one by the second one. I'd have x to the 4 is equal to b times c. Whether that would go anywhere. Whether I divide more things through by those. I could divide the bottom one by the top one. X to the 8 is a times c squared. Does that work in some way? Which would then square those, square the top one. I'll be saying that, oh, I don't know. Well, yeah, if I square the top one, I'll get a is b squared, which is what I've got over here. So that looks like an interesting way to go about it, maybe, doesn't it? If a is b squared, then, yeah, I suppose I could go through that way. I don't know. This seems fine. It seemed quicker doing it that way. But if I got a is b squared, I suppose it probably would drop out, wouldn't it? Because I'd have, I feel like I want to finish this now. So b to the 4 times c is x to the 7. Well, actually, it's just write it on here. B to the 4 times c. That would be b to the 5 times c squared. That would be b to the 6 times c cubed. On all of those, I mean, yeah, you can see it's then pushing it towards just by looking at it that c is b cubed, and then everything works for x being b. So yeah, you can go about it that way as well. It's quite an interesting question. Either way works. The graph of the quadratic, that where p is greater than 0 intersects the x-axis at 2 distinct points, right? So it's got 2 roots. Which of the following graphs does the shaded region show the complete set of possible values that p and q could take? Okay, right, there's quite a lot of options. So we've got 2 roots. So we got our b squared minus 4p. Okay, we've got that is greater than 0. So q squared is greater than 4p squared. Okay, and I've got that p is greater than 0. So what have I got for those then? Q squared is greater than 4p squared, so it's not any of the top. For f's looking good, isn't it? Because it's got to be above the lines. We're going to get the 2 solutions. 1 goes to 2, so yeah, it's going to be f. It just fits with that. Q squared is greater than 4p squared. Nothing else looks even like it. I mean, we've got to have two solutions. It's only F and H that have got the right sort of shape, and H doesn't fit with that multiple of 4 on the p squared. So that's pretty straightforward. A multiple choice test question offered the following 4 options relating to a certain statement. Given that exactly one of these options was correct, which one was it? So exactly one of these is correct. Well, if you got B, you're going to get D. That doesn't work because it's true if X is greater than 1. So it'd also be true if X is greater than 2. So it's not going to be B. Then can we do those with the other? So then if and only if. Well, if it was A, if and only if, it'd also be true for B. So it can't be A. Then we could say the same for C and D. So it'd have to be just D. Because if D was true, exactly one of these is correct. So if we had D, it's true if X is greater than 2. That doesn't necessarily mean that C is going to be the case, but it would the other way round, C for D. It rules out B and it rules out A, so D. Consider the following inequality. A is a real constant. Which one of the following describes a complete set of values of A such that that is true for all real X? Okay, let's draw some pictures then on this. So X minus 2 mod looks like that at 2 and 2. And then we've got A mod X plus 1. And we want this to be, we want that line, this thing here on the left has got to be below that everywhere. So it's going through 1. So as X gets more and more negative, so we've got to have, we don't really care too much what it's doing over here, as long as it doesn't go up beyond that line. But it can do any old thing. Going this way, it has to not cut. I mean, the most it can do, if that's at 1, is have a gradient of -0.5. If it's got a gradient of -0.5, it will just touch here at 2. X is 2. So we can't do more than that for A. Then, and if it's got -0.5 on it, well, I mean, anything that's happened over here is going to be all right, isn't it? Because, yeah, I mean, -0.5 is still going to be fine. I mean, that's going to be, it's never going to catch up with this thing. I mean, that is the limiting point, isn't it? When we're over here, and then we'd have, yeah, A mod X. So that would still have that gradient of -0.5. So, yeah, and that does just seem to be it. Providing we've got a gradient steeper, more negative than that, we're all right. So that's E, or equal to that, because we're allowed it to touch. We've got a less than or equal to. But yeah, that's the critical thing, is we're going through 1 on the y-axis. We've got 2 on the x-axis where the mod graph's going. We just need to not intersect it. Just touch that point rather than going through the graph. So 18, E. 19, find the value of that expression. That looks fairly ugly, but so why have they written it like that? Why have they not put 9 minus rule? Oh, right, because we can factorize it. Yeah, that's 2 root 2 minus 1 squared. Because that would give 8, 1, and minus, yeah. And then they must have done the same with this then. So it's going to have to be a 3 and a 2 root 2 and a minus squared. And then we're adding those, so just get rid of those when we square root. So we've got A cancel, and we've got 2, E. Okay. Kind of telegraphed that one a bit, didn't they? When the graph of the function y equals f of x, defined on the real numbers, is reflected in the y-axis, then translated 2 units in the negative x direction, the result is g of x. Right, so we're starting at f of x, then we're reflecting in the y-axis. So that's going to f of minus x. Then we're translating 2 units in the negative x direction. So we want to change x for x plus 2. So that's going to be f of minus x plus 2. So that is f of minus x minus 2. Okay, so that is g of x. When the graph of the same function, y equals f of x, is translated by 2 units in the negative x direction, then reflected, then we get h of x. So f of x goes to f of x plus 2. And then we're reflecting, so x goes to minus x, f of minus x plus 2. And that is h of x. Okay. Which one of the following conditions on y equals f of x is necessary and sufficient for these things to be identical? So we want f of minus x plus 2 to be equal to f of minus x minus 2. So, well, say that was u, f of u, then we've got f of u minus 4. Oh, right, they've just done it the other way around. It's going to be b. So I could say that was, yeah, if I called the one on the right f of u, then that will be f of, yeah, that's right, u plus 4. Okay, so b. No, it's always fiddly, those transformation ones, but they're not that bad. You just plug in what's happening step by step. I think the main thing that people sometimes get mixed up with is when you're doing the reflection and the translation, what bit you're changing. So the reflection, you're just changing the x goes to a minus x. And then when you're doing the translation, the x goes to the x plus 2. So that's how you keep track of where your minus signs are going. So just keep an eye on those. That was a weirdly quick paper. I think there was very little to do in the way of calculations or algebra. They mainly seem to be logic questions. There were just loads of them, where it was just, okay, I mean, that one there was some working out, but I did question 15 twice, so it didn't have to be that much working out. But otherwise, I mean, these are all just logic questions, so kind of strange, really. I mean, where did I do any algebra? Or, I mean, I haven't really so far. I mean, like nothing at all the way through it. Very strange. So I'm sure there was one. Here we go. Question 2. I think it's about the only one where there was any working out to do. Everything else was logic questions. So that was a strange sort of paper. It was quite nice, but it seemed pretty quick. I mean, I didn't even think about splitting that into 2 videos because it just flew through, really. So there you go. That's 2019 done.